We've got the PocketQube development team joining us from America. I've already said that. They're just middle school students and age 13 and 14. They're going to be talking about educational benefits of PocketQubes in a pre-college setting. So yeah, I'll let you guys take the stage. When you guys got the mics up.
Hello everyone, I'm Kenan. I'm here with my colleagues Zion and Winston. We are from the Green School in South Florida in the United States of America, and we're excited to present to you all the educational benefits of PocketQubes in a pre-college setting.
So to start, I'd like to introduce who the Wolfpack CubeSat development team is. The Wolfpack is a group of students aged from 10 to 19 who design, build, test, and launch CubeSats. Along with this, they also publish children's books to teach students about aerospace and to help them get interested within that field. Their mission is to prepare students to design, build, and launch CubeSats into space, and they do this by employing a philosophy known as blue sky learning. So blue sky learning is a philosophy that has students create a ridiculously difficult goal and have them achieve this by actively visualizing success. And in order for students to achieve their goal, they need to have a growth mindset and need to endure, persevere, and strive. The Wolfpack also embraces a techies and talkies approach, in which the techies are the kids who want to work on CubeSats, and the talkies are the ones who want to actually go to these different conferences and present the papers that they've written. So now I'd like to talk about some of the CubeSats that the Wolfpack has actually launched. The first CubeSat is WCDT-1, which was a 1U CubeSat based on the Near Space Launch Bounce Bus structure. This was a major achievement for the Wolfpack, as it was the first CubeSat ever launched by middle school students in the US. Its mission was to validate a lab-on-a-chip system to test the viability of extremophile bacteria, and this proposal was selected through NASA's program called the CubeSat Launch Initiative in the 8th round on February of 2017. It was launched from Vandenberg Air Force Base in California on the 3rd of December in 2018. The next CubeSat that we've launched is CapSat-1, which was also a 1U CubeSat based on the NSL fastbus structure. This was primarily an educational tool to have students learn hands-on learning, and the mission was to test the efficiency of capacitors in place of lithium-ion polymer batteries. This was also selected through NASA's CubeSat Launch Initiative on November of 2018 and was launched from Kennedy Space Center on the 15th of July in 2022. Next we have FlipSat-1, which has already been integrated and will launch next year on March 1st. This had two missions. The first was to evaluate the effectiveness of hardening technologies, and the second mission was to establish spaceflight heritage for microbit processors. Originally, it was going to be a hosted payload on a Sherpa ring, but now it's going to be a free flyer inside true hardware. Finally, we have our upcoming mission, WolfSat-1, which will also be a 1U CubeSat, and its mission is going to test a bacteria known as Ideonella sacensis and its ability to digest PET plastic in space. And how we're going to be measuring the plastic digested is through a light-emitting diode. And this is extremely significant, as if we can determine if Ideonella sacensis can digest this plastic, crewed space missions can find a way how to get rid of the single-use plastic.
And now let's discuss the Green Aerospace Team, or GAT. The GAT is composed of a group of dedicated middle and high school students ranging from the ages of 11 and 18. And as they are still in their nascent stages, they are mentored by the Wolfpack, who are very experienced in the world of aerospace. And this collaboration has created a joint vision to teach students critical skills and to inspire the younger generation in STEM education and for them to pursue it in a very fun way. What's quite exciting is our inaugural project, which we hope to launch by 2025. So this is the GreenSat-1, and this is made possible by our collaboration with the Near Space Launch Team. And this CubeSat is a 1U fastbus structure which has flight heritage and a technical readiness level of 9. The objective of this payload is to implement machine learning algorithms to validate the operation of microfluidic devices on the bone fluid forces. And this is very impactful because we can better understand the effects of microgravity on the skeletal structure. So in the future, we may be able to have longer distance space missions. So let's discuss the importance of small sats in the US. So these innovative satellites have really impacted space exploration as they facilitate many advanced research, such as Earth observation, telecommunication, and space science. They also allow for rapid experimentation, which is crucial in this field where technological advancements occur very rapidly. And they impact education a lot because they make these satellites accessible to a larger amount of students and organizations, which helps these students have more direct, hands-on learning opportunities. So we all know the PocketQube. Robert J. Twiggs pioneered the CubeSat and then developed the PocketQube standard, and he created a new era in the, it's wrong up there, but it's the pico satellite class. It was aimed to democratize access to space and to boost space exploration. And there is a lot of evidence of this impactfulness as there has been a widespread adoption of PocketQubes in the aerospace industry. Like companies like Alba Orbital, which we all know about, but I would like to quickly talk about. They offer platforms and for buses for people to be able to launch their PocketQubes, and they also help payload integration. And I think what they're doing is really inspiring because their mission is to democratize access to space, and they have really enforced Twiggs' idea to do so. As the leading PocketQube company, they have 41 successful launches, the notable ones being the unicorn satellites. So let's consider the comparisons between the CubeSat and the PocketQube. So the CubeSat is a 10 by 10 by 10 centimeter cube dimension, and one CubeSat is denoted as 1U. 1U, the mass of a CubeSat, 1 unit of a CubeSat is approximately 1.333 kilograms. And compared to the PocketQube, the PocketQube is a 5 by 5 by 5 centimeter cube dimension, with one PocketQube unit being denoted as a P, and its mass being approximately 250 grams. And what's quite interesting is that the PocketQube is actually much more of a dense satellite than the CubeSat, as its mass is 1/4 of the CubeSat's, and its dimensions being 1/8. They are very cost effective and, like I said, very compact, which creates a lot more satellite deployment opportunities.
Next, I'd like to talk about the advantages of PocketQubes. So PocketQubes are a budget-friendly option, especially for small businesses, organizations, and schools. And this makes it ideal for STEM education because of its small size. They're a lot more affordable than CubeSats. And the cost-effective nature of PocketQubes promotes the growth of the space economy, which space is every day is growing and soon will be $1 trillion sector. That's very important. And PocketQubes also have the potential for grants due to a few launches that have actually occurred. So now let's compare the PocketQube versus CubeSat cost. So 1U CubeSat costs roughly $50,000 to $100,000 to manufacture, and a 2U and above CubeSat costs from $250,000 to over $1 million to manufacture. And launching these CubeSats can cost over hundreds of thousands of dollars. So as you can see, CubeSats are very expensive, so it doesn't really make it a really viable option for schools or businesses with small budgets. So that's where the PocketQube comes in. A 1P PocketQube roughly costs $5,000 to $50,000 to manufacture, while launching it can cost from $20,000 to $50,000. So this makes it a lot more ideal as an educational tool due to its affordability compared to the CubeSat. So, like I stated, PocketQubes are ideal for testing new technologies in space, particularly communication systems as well. And it allows the evaluation and improvement of these technologies and allows these technologies to go from theoretical concepts to practical application. And due to its small size, 50% of the volume of the PocketQube can be the payload itself. So now the benefits of PocketQubes for hands-on experiential learning. So PocketQubes serve as innovative tools in STEM education, and this is shown through David Kolb's theory, which has 4 distinct learning styles. The first is concrete experience, which essentially has students actually doing the experience and actually doing the hands-on learning. Next comes reflective observation, where students actually reflect on the experience that they just had and actually conclude on these experiences. Next is abstract conceptualization, where students actually learn from the experience they just had and gain the knowledge of that hands-on learning experience. And lastly comes active experimentation, where students use the knowledge and the soft skills, executive functioning skills that they gain from the hands-on learning experience and actually apply it to other experiences that they also have. And PocketQubes allow students to gain soft skills, executive functioning skills as well, such as critical thinking, problem solving, teamwork management, and project-based management skills.
Moving on to STEM education. PocketQubes provide a great way for students in middle and high school to get real-world science and engineering skills which they wouldn't have otherwise. It also involves students in the design all the way to the launch process. Whilst PocketQubes promote science and engineering skills, they also build teamwork, problem solving, and project management, which are all great skills not just used in the STEM field. PocketQubes can be used for middle and high school projects, but they can also be used for projects in the college environment. PocketQubes can also promote international partnerships with business and schools that are in countries that wouldn't otherwise be considered. PocketQubes can also be used in the highest level of STEM fields in scholarly research projects, and they're a big advancement in space technology with how the space economy is growing so rapidly. Now let's discuss a successful PocketQube launch. BeakerSat-1. BeakerSat-1 was created by students from Morehead State University and Sonoma State University, and it was launched by UniSat-5 in 2013 and re-entered Earth's atmosphere in 2019. It is of the 2.5P form factor, and its mission was to validate and verify all components of the PocketQube in a real space environment. Now to ROM2. ROM2 was a satellite, and it's so significant because it was the first satellite launched by Romania. It was built by the ROM Space satellite team, which consists of high schoolers, and it was launched in 2023 with the help of Alba Orbital by SpaceX and Vandenberg. The nickname for this PocketQube was the Space Sparrow because of its small size and its mission, which was to observe the Earth using a 2-megapixel camera.
And now to recap, I would like to talk about, again, how PocketQubes are really effective in STEM education. Obviously, their development time is very short, some of them being able to be developed in under a year, which makes them very implementable into the curriculum. And they're also very useful to teach many subjects like physics, math, and computer science. They also do teach essential skills like engineering and many other skills that can be used in fields not just in aerospace. And we have seen many uses of CubeSats and PocketQubes in the past, like ROM2, which has been launched for educational purposes. We would like to give a big thanks to Mr. Walkichop and Mr. Reza and the whole Alba Orbital team for giving us time today on the stage, and for all the love and hospitality in the past. And thank you to you all for listening to our presentation. Any questions?